Awesome. Thank you. All right, so we are going to go over the answers for worksheet 1 in uniform acceleration or uniformly accelerated motion model, worksheet 1, development of accelerated motion representation. So, I know, isn't it huge? All right, so we talked about this first. So I said, okay, the first question's asking for between T0 and T6, what that slope would be. What did you guys get? 30. How did you get 30?
y2 minus y1 over x2 minus x1.
Okay, so it went up 180 and over 6, right? And so you get 30. What about the purple one? How much did the purple one go up?
30.
So this one, I think, started at 20, right? And at 4 seconds, it was where?
80.
80. So that means the rise is 80 minus 20, because that's how much it went up, divided by how much it went over. So that's from 4 seconds to 2 seconds. So 4 minus 2. So we get a slope of 60 over 2, which is 30. Are we good with that? Okay. Then for the next part, you found your tangent line. The tangent line is where the line is parallel to your graph. So we picked out a tangent line that matched your graph. I expect that everyone got a slightly different tangent line because it depends on how you drew it. I'm hoping that everybody has a very similar tangent line because you all started with the same graph. So your answer to 6 was 30, answer to 8 was 30, and number 10, I'm going to go around the room and I'd like you guys to tell me what are the slopes that you got. Table 1, what'd you get? 30 what? 33 over 1. I'm just going to write 33. Group 2, give me 1 or 2 slopes that you guys got. 30. Anybody else get a different slope at that table? Nope. All right. This group, what'd you guys get? 30. That group, what'd you guys get? 35. What did you guys get?
31.4.
31.4. Back table. 40. What'd you guys get?
31.75.
31.75. Cool. All right, looking at everybody's numbers, what do you think I expected you guys to get in terms of your slope? 30. So I know that you guys did not all get 30, but I expected you to get about 30. So when we compare them, they are about the same. So the slopes are similar or the same, depending on. Okay, so you're going to either tell me that they're very similar or close, or you're going to tell me that they're exactly the same. It depends on what slope you got. Do not change your slope just because somebody else got 30. Does that make sense? Yes? Cool. Alrighty, so the last thing I want to do is I want to go back up here and look at number 2, 3, and 4. What is the significance of the slope of a position versus time graph? Good. So if we're looking at slopes, you told me 3 things though. You said how far, how fast, and how much it's speeding up. What does the slope of a position versus time graph specifically tell you? It's one of those 3. We use a position versus time graph to get what? Yes! The slope here is the velocity. Okay. And then it says, what is happening to the slope of your position versus time graph as time goes on? What's happening to your slope? Your slope is getting steeper. So the slope is getting steeper. Okay. Explain what your answers to question 2 and 3 tell us. What does 2 and 3 tell us? So 2 says what? Tell the people at your table. What does 2 say?
Velocity is getting faster.
Okay. And what does 3 say? Thank you. So we've got the slope is our velocity. And we have that the slope is getting steeper. What does that mean is happening?
Velocity. More velocity.
Yes. This means that the velocity is increasing. So the object is speeding up. All right, are we good?